so we're going to start with lesson 9.7. This is something you guys should see on Google Classrooms. Under each lesson, you'll have my notes, okay? So instead of writing out the definitions like I do in class, you can just have them instead, okay? So 9.7 is vectors, and a vector is going to be a quantity that has both a magnitude and a direction. What that means is magnitude is a number to it, right? So how long is the vector? And then direction tells us which way is it going. So the magnitude, we just use the distance formula to be able to find how long this vector is that starts at point A and ends at point B. So a vector looks like a ray. It has an initial point and a terminal point. Okay? When you're naming it, the initial point goes first and the terminal point goes second. And then above it, you draw a ray. So it's saying I start at A and I move in the direction of B. Okay, so its magnitude tells you how long it is. And that's just the distance formula. Okay, so the square root of the difference in their x values squared plus the difference in their y values squared. And then the direction, we have to decide which way is it going, right? So vector AB, like this, is different than vector B to A because it's saying B is our initial point and A is our terminal point, okay? So with a vector, we write it in component form. So it looks a lot like an ordered pair because you have your initial point and your terminal point, and the x-coordinate of it is going to be the difference in their x values, and the y-coordinate is the difference in their y values, okay? But as a vector, you're going to put it in pointed brackets instead of round brackets, like we would an ordered pair, okay? The first number tells us how we move from the initial to the terminal. So if this was 3, it would mean that we would move 3 to the right, because that's the x. And then if it said -2, it would tell us we would go down 2 to get to our terminal point then. Okay, so to work through it, right? If you're given 2 points, so say P and Q, right? So point P, like we see, is at, we're going to say 0, 1, and point Q is at -3, 5, okay? Then if we want to find the component form and the magnitude, right? This is ray PQ, where P is our initial and Q is our terminal. So in component form, we would go from the terminal point to the initial point. So we're going to do -3 minus 0, and then 5 minus 1. Because Q is our terminal, that's where we're ending, and P is where we're starting. So in component form, we would say this was vector -3, 4. Okay, again, pointed brackets. It tells us that we go from point P, you start at 0, and you go -3 in the x direction, so to the left, and then you go up 4 in the y to get to your terminal point Q. Okay, and then its magnitude is how long is it. So that's where we use the distance formula, and it looks like you're taking the absolute value. So it's PQ in absolute value signs. That tells us it's the magnitude or how long it is. So then that's going to be -3 minus 0 squared plus 5 minus 1 squared, and then take the square root of that. So -3 squared plus 4 squared square root, which is 9 plus 16, and then the square root of that is square root of 25. So the magnitude PQ of vector PQ is 5. How long is it, right? It is 5 units long, okay? So that's if you're given an initial and a terminal point. You can find its component form and its magnitude, okay, by difference in the x, difference in the y, and then magnitude is just the distance formula, okay? then we come to the direction, right? If you look back on the next page of your notes, okay, that I posted for you guys, direction, it's going to be determined by an angle. So that's where we're going to use our trig ratios, okay, because it has to be the angle that the vector makes with the horizontal line. So basically with the x-axis. So you're going to take your vector, and even if it's not oriented at the origin, so its initial point's not at 0, 0, we can shift the x-axis and just draw our horizontal line here, and then we're going to find this angle, and we're going to reference it with relative to the north, south, east, and west. So horizontal lines represent the north, south, and then vertical lines represent the east, west, right? I'm sorry, reverse that. So the horizontal is the east, west, right? Like we see here. So north, south, east, west. So if we were to travel directly this way, we would be traveling due east. But we're above that, so we're in the north of the east, okay? So if you're traveling this way, or up here, right, it would be west, but then you're north of west. So it depends on which quadrant you end up in the coordinate plane, how you determine the direction, okay? So looking at the direction of this vector, right, we have here's your axis that you started at. Point A is here. It's our initial point, and point B. We say A is at 100, 200. Okay, and B is at 600, 300. Okay, so again, the vertical is north and south, and the horizontal is east and west, just like a compass, okay? So when you're looking at the direction, it's like you're taking your axes and you're shifting them up here. So now this is directly east, and we're going to find this angle, okay? So we can find, because this is in component form, this is the difference in our x and the difference in our y. So we're going to end up using tangent, because we know the tangent of an angle is the side opposite the angle over the side adjacent. So for finding the angle created from the horizontal, the opposite ends up being the difference in your y values, and the side adjacent ends up being the difference in your x values. So we can say that the tangent of angle A is going to be 300 minus 200 over the difference in your x values, so 600 minus 100. So the tangent of angle A is 100 over 500. And then we know our inverses. So we can take the inverse of angle A, or the tangent inverse of angle A, to get the measure of angle A by itself, and that's going to be the tangent inverse of 1 over 5. And you would have to use your calculator for that, right? That's not something we know how to find. And when we do that, we know we end up getting that the angle is 11.4 degrees. But because it's a direction, 11.4 degrees what? Right? We're traveling it. So if this was the east, we're going towards the north, so we would say the direction is 11.4 degrees north of east. And you always reference the east and west, right? So if it was over here, we would say it's north of west. Or if it's down here, you would say it's south of west. Or over here would be south of east. Okay, it's always referenced to the horizontal east and west direction. Okay, the magnitude would be the speed if you're ever asked for that. All right, so that is magnitude and direction of a vector. With vectors, we are able to say that two vectors have the same magnitude and the same direction, okay? Magnitude would be they're the exact same size. The same direction would be they'd have to be traveling with that same angle and the same direction relative to the east-west. Only then would the two vectors be equal, okay? So if we look at A and B, vector AB and CD, okay, they have the same direction. They're forming the same angle with the horizontal. If we were to find their magnitudes, if they're equal, the same length, then the two vectors are equal, okay? So vector AB and CD are equal vectors. If this vector started at B and terminated at A, so vector BA, we would say it would be parallel to CD, but not equal, because parallel would be, it happens when they're traveling in the same direction or opposite directions. To be parallel, they don't have to be the same length, okay? So these two vectors here, vector GH and EF, they are parallel vectors because they're perfectly horizontal or perfectly vertical. They are not equal because they're not traveling in the same direction, and they don't have the same magnitude, so they're not the same length, okay? All right. You can also take two vectors and add them together. Two methods of doing that. You can use them in the coordinate plane. One method is something called the tip-to-tail method, and the other is called the parallelogram method. So parallelogram method, in my opinion, is a little repetitive because you end up taking your two vectors and forming a parallelogram and then finding the diagonal, okay? So a little more steps involved there. The tip-to-tail method, I don't know if the book actually shows it to you, but what you do in the tip-to-tail method is you take your first vector, and it'll be in component form, so you can start it at the origin and then draw the first vector, so its initial point to its terminal point, and then put the initial point of the second vector on the terminal point of the first vector, okay? So what that means is you have one vector and you draw vector V or U, whichever one you want to start with. And then to add vector V, you would put the initial point here and then draw vector V. And the sum of the two ends up being starting at this initial point and ending at this terminal point. Okay? The parallelogram method has you drawing your first vector here, and then you're putting them both starting at the initial point, and then drawing in both vectors to form a full parallelogram, okay? You can also add vectors algebraically. So to do that, vector U in component form would be, say, A1, B1, and vector V in component form would be A2, B2. So to add them, you simply add your x coordinates and add your y coordinates. So the sum of vector U plus vector V would be A1 plus A2, B1 plus B2. Okay? Kind of like just adding two coordinates, right? Add your x values, add your y values, get your new vector. But remember, the arrows mean vectors, okay? So that tells us how to get from one point to another. So we're going to say vector U is defined as 5, -1, and vector V is defined as 3, 4. So if I want to find vector u plus vector v, okay, in the coordinate plane, a vector tells us how to get from one place to the other. So I'm going to start with vector u, and I'm going to put it at the origin. So this first value tells me I go 5 in the x direction. It's a positive 5, so I'm going over 5. So 1, 2, 3, 4, 5. This tells me I go down 1 in the y because it's negative 1. So here would be vector u. Okay? Then I go along and I add vector v. And I'm going to start vector v where vector u ended. So here, okay? So 3 in the x. So I go over 3. And then 4 in the y. So I'm going to go up 4. So there's 1, 2, 3, 4. So to the right 3, up 4. This defines vector v. Okay? Then that tells us that if I start where u started and end where v ended, I will have my sum. So this would be vector u plus vector v. And we can check that that works algebraically, because vector addition, I'm going to add my x coordinates and add my y coordinates. So the sum should be at 8, 3. Okay, so if I were to find this, I would go over 8 and up 3, which happens to be vector u plus v. So that is lesson 9.7.